Hello, this is Ms. Grosch, and the topic for today's lecture is Under the Crust. Now, when you think of the Earth, you might think of that round sphere, but as we know, the Earth is not actually a nice, smooth, round sphere. It's got lots of bumps on it that we call landforms. Many of the landforms on Earth are created by weathering and erosion, deposition, things that happen on the surface of the Earth because of different environmental forces. But there are some landforms that are pushed up from below. So to understand where those landforms come from, we have to understand the structure of the Earth, which is really rather complicated, especially because the Earth is so big that it's hard to really see what's under its surface. But this is the information that we are feeling pretty sure about. First, some facts and figures. How big is the Earth? Well, if you could travel from the surface of the Earth to its center, you'd have to travel about 6,400 kilometers. And as you went deeper and deeper into the Earth, you would find that the composition, which is what the Earth is made of, and the texture, like the state of matter you were in, would change. So what are the changes that you would notice? The first change would be temperature. If you're walking around on the surface of the Earth, it is on average about 20 degrees Celsius, which is normal room temperature. Of course, it might be different in different places on Earth, but just on average about 20 degrees. However, if you could go down below the surface and head towards the center of the Earth, you would find the temperatures getting hotter and hotter until finally they'd end up hotter than the surface of the sun. Now, you have to keep in mind that we haven't actually been down to the center of the Earth. The deepest hole that humans have ever dug is in Russia, and it's only about 12 kilometers deep, which doesn't even get you down past the crust. What this means is that we have to use what we call indirect evidence to figure out what's going on down below the Earth's surface. Indirect evidence is when we make observations about things that we can see or measure, and then use that to figure out things that we can't actually observe, either because it's too far away, too big, or too small for us to actually see it. One example of the kind of indirect evidence that scientists use to figure out some things about what's inside the Earth is earthquake waves. When we have an earthquake, we can measure how fast those waves of energy travel from one part of the Earth to the next. And scientists know that there are some forms of earthquake waves that just can't go through liquids. So when earthquake waves bend or stop traveling, that lets us know that there's a part of the Earth that's a liquid. Another kind of evidence that scientists use to figure out what the Earth is made of are meteorites. There are chunks of material in space, usually they're pretty small, that float around and were made at the same time that the Earth was made. They should be made of the same kind of material as the Earth, but when they fall to Earth and they get preserved, we can study them, and we found that they have a lot more iron than what we have on the Earth's surface. So this has told scientists that there's probably more iron in the Earth than what we can see. Most likely, it's down below the surface somewhere. Using these kinds of indirect evidence, scientists have decided that the Earth probably has 4 distinct layers. They're distinct because of the material they're made of, and also because of their state of matter. The names of those 4 layers, working from the center to the outside, are the core, which we divide into the inner core layer in the very, very center, and then also the outer core, which is above it. Above that, we have the largest layer, which we call the mantle. It actually has several different parts that you'll learn about. And then finally, there's the crust, which we've already started talking about a little bit. Okay, so you should know some information about these different parts. Let's start with the crust. Although there's lots of different kinds of rock on the surface of the Earth, when we get down below the surface to where the crust really begins, you mostly find it made of 2 different rock types, basalt and granite. They're both igneous rocks, And usually you find the basalt, which is quite thin and very dense, under oceans, and then the granite, which is less dense and thicker, is found under the continents. Even though the crust can be quite thick in areas, it's really only about 1% of the total size of the Earth. If we go down below the crust, we find the mantle, which is the thickest layer. It's made of minerals that are very hot, but they're not quite hot enough to be melted. They're not liquid, but they are hot enough that you could spread them around like peanut butter if you had a big enough knife and weren't worried about dying. So we say that they flow, kind of like asphalt. That's a little bit simplified, though. The mantle actually has several different layers. The top of it is called the lithosphere, and actually the lithosphere contains the top part of the mantle and also the crust. It's very brittle. It's solid. And underneath it, you have another layer of the mantle, which is much more slippery. It's also hotter, and that's called the asthenosphere. Now, those two layers together are very important because they allow certain things to happen. And we're going to talk about what happens in just a moment. But first, we should probably go through the other two layers of the Earth, the inner and outer core. Both the inner and outer core are made of the same kind of materials, iron and nickel, which are metals, and they're extremely hot. Those metals are hot enough to be melted. But we consider them to be two separate layers. Even though the outer core and the inner core are both made out of extremely hot iron and nickel, the outer core is liquid because that iron and nickel are melted. In the inner core, the iron and nickel are solid, even though they're just as hot, if not hotter, than what's in the outer core. Why would that happen? Well, because there's so much weight of all the other layers pressing down on that very center part of the Earth. Even though it's hot enough to be melted metal, it is a solid, not a liquid, in the inner core. Understanding the structure of the Earth has helped scientists to develop a theory, which is called the theory of plate tectonics. This idea says that the Earth's crust isn't a solid single piece. Instead, the lithosphere is broken into giant pieces that we call tectonic plates. And they slide around on the asthenosphere, which is the slippery part of the mantle. If this is true, it helps to explain why certain things happen. Things like the development of mountains and volcanoes, it explains earthquakes. And it does it because the boundaries, the places where two plates meet, have a lot of action going on. What the theory tries to explain not only is that these plates exist, but also what causes them to move around. And it's because scientists believe that the mantle is actually moving. It's moving in a circular pattern called a convection current. So you have the Earth's crust divided into these big pieces called tectonic plates, and those pieces, which are mostly the lithosphere, the brittle part, they float around on the asthenosphere, which is much more slippery. Now, the heat from the Earth's core makes the lower part of the mantle, the asthenosphere, much hotter than the upper mantle, and it's the differences in temperature that can cause the mantle to start moving around. When things are hot, they're less dense, and when things are cold, they're more dense. So the hot mantle that is nearer to the core, it rises because it's less dense, and the somewhat cooler mantle that's above it sinks because it's more dense. This produces a circular motion that we call a convection current. That moving mantle carries the chunks of lithosphere that we call tectonic plates around with it. And in the spots where they connect with other tectonic plates, those places called plate boundaries, well, their motion causes all kinds of things to happen. We have four basic kinds of plate boundaries. The first one is called a divergent boundary, where two plates move away from each other. When two plates push apart, usually magma bubbles up from below the surface of the Earth to fill in the gap. If this happens under continental crust, then you end up with a land feature that we call a rift valley. If it happens under the ocean, then you end up with something called a mid-ocean ridge, which looks kind of like a mountain range, but underwater. Another way that plates can move is called a convergent boundary. And in this kind of motion, two plates collide together. If this happens where a continental plate collides with an ocean plate, the ocean plate, which is thinner and more dense, will get pushed down below the continental plate. This will allow it to melt back into magma, and it can produce both an ocean trench and a volcano. On the other hand, if the convergent boundary is between two continental plates, then they'll really just crumple up and form a tectonic mountain range, like the one you see in this picture. And finally, if two tectonic plates push in opposite directions but sort of grind against each other, you can end up with a very extreme motion that we call an earthquake. And that brings us to the end of this lecture. I know it was a long one, but you know what? There's a lot of stuff going on under the crust. Thanks for listening. I'll see you in class tomorrow.